All right, last one, 104, exponents, logs, and e. Okay, so really we're talking about the e rule and the natural log rule, okay? So we will get more specifically into all logs and all exponents next year, but for now we're going to talk about the e and the ln rule. So really this should say like e and ln rule. Sorry about that. Okay, so there's only two rules, and they're pretty easy to remember. So here is each one. The derivative of e to the anything power is exactly the same thing times the derivative of the power. And then for ln, the derivative of ln of anything is 1 over whatever that is times the derivative of whatever that was. So I'm going to give you some easy examples to start with. Am I going to give you easy examples? Kind of. I'll give you one easy example over here, okay? So let's say you're taking the derivative of ln, 2x. So that one's super easy. The derivative of ln 2x is going to be 1 over 2x times the derivative of 2x, which is 2. And that would be 2 over 2x, which is 1 over x. So the derivative of ln of 2x is going to be eventually that, because this is 2 over 2x, which is 1 over x. Okay, so that's how that works out. This one, a super easy version. You don't have to write down. E to the power of, 5x. When you take the derivative, would be e to the power of 5x. You just literally write the same thing, times the derivative of the 5x, which is 5. So 5e to the 5x. So there's super easy examples of each rule. So that's how you would use each rule, okay? So one thing to remember is your log rules. So it's been a little while, but we did do this year also. So don't forget about your log rules, as in, when you have ln of AB, what can you do with that? How can you change that? Well, you can expand it, and it becomes ln A plus ln B. Same with division and subtraction, right? When you expand or when you condense, if you go the other way, it becomes this. And then there's one more log rule that's very, very popular that we need to remember. It's the power rule. So ln of A to the power of B, the B comes forward. So you guys know these already. It's been years, okay? Literally years. Okay, so we're going to jump into examples. So find the derivative of the following. So A, let's say you have something like this. So we're really going to jump into it. The derivative of y would be a product, because this is a product rule. So I did my little underline to show you instead of a box and a triangle, but that's the same kind of thing, right? So why don't you just write it out? Write out that first step. Y prime equals, and then what plus what? Just try it, and then check it. So I got something like this. So here's my box, here's my derivative, which is the same thing, of the triangle, and then here's my triangle and the derivative of the box. And then I clean it up a little bit, and I would say all I can really do to that is factor out. So I can factor in that should be e to the x. I'm going to fix that now, otherwise it'll drive me all crazy. Okay, sorry. There we go. Okay, much better. So factor out an e to the x, and then factor out an x cubed. There's an x left over here, and there's a 4 left over here, so x plus 4. All right. Okay, B. Let's try another. So B, y equals negative 12 e to the power. So what do you do when there's a number in front? You leave it. So here's my negative 12. I left it. The derivative of e is exactly the same thing, times the derivative of the power, which is a 2. So that is basically the final answer, but I'm just going to multiply everything by 2, and then final answer done. Not much more you can do to it. Okay, let's get a little bit more interesting. So I think you should try this. So give it another try. So this is, again, a product rule. So it's 3x times this quantity. Okay, here's another thing that you could do. It is up to you. So you can also rewrite this as a fraction. right? Can't you rewrite it as 3x over e to the x squared? And then instead of using the product rule, you can do the derivative of that, which is low D high less high D, low denominator squared below. So you can do that instead, and you will get the same answer. I think you should give it a try. You really do. Okay, first step, right here. So box, triangle prime, triangle, box prime, and then I go ahead and factor out a little bit as much as I can. And right here is my final answer because I got this and I want to put it on the bottom because it's weird to have like a negative exponent. Okay. Okay. Second to last one, I'm going to do this one. Well, there's 3 more, but that's okay. So this one is definitely a product rule. So you have an E, you have an ln, and then you're going to do the product rule with that. So try that first step. What's it going to look like? What plus what? Just give it a try. And then I got that. So here's my box. Here's my derivative of the ln, the derivative of the triangle, plus my triangle, and the derivative of the box, the derivative of the e. And then I clean it up a little bit. And all I did was like I multiplied it out, right? So I just rewrote that as a fraction, and then I wrote that. Can you factor out an e to the 2x? Yes, absolutely. You can write this another way. That's just one way that we can write the answer. Okay. Oh, I was wrong. I think there's more than. All right, I was wrong. Okay, this one's really good. This one's really, really good. Okay, I'm gonna make it a little bigger. So y equals ln of the quantity ln of the quantity x squared plus 13x plus 2. So what I did for you is I put a little green box around that final quantity. That belongs to this ln. And then this big ln has that orange box, basically. So if I didn't put a whole box around it, but the main ln is this whole thing as a box, just that orange part. Okay, so this has like a box within a box. It's sort of like Inception style. I don't know if you watched that movie, but something within something, okay? So to take the derivative, I have to take the derivative of this ln. So first and foremost, it's an ln. So it's going to be 1 over the orange. All right? So I have 1 over the orange, right? And then I'm supposed to take the derivative of the orange. Well, what's the derivative of an ln? The derivative of an ln is 1 over. So the derivative of the bottom is 1 over this. And then this ln has its own box, so now I have to take the derivative of that box, which is a 2x plus 13. And then all you can really do to clean that up is put this as a numerator and maybe put this in front because this is an ln, so we don't want to leave this in the back. So here's what I mean. Final answer done. A little bit interesting, right? You can do it. I have faith. Okay. F. So this one is just a straight natural log. Oops, sorry. It's just a straight natural log. But you have to realize that this is a quantity, right? And what power is it? All right, so we're going to start with the derivative of an ln, which is 1 over this. So here is 1 over that. I'll cover this. And then, what is the derivative of your box? What is the derivative of that? Well, that's a quantity to the 1/2 power. So the 1/2 comes forward, and then you have a quantity to the negative 1/2 power because you minused 1 from the 1/2 power to get negative 1/2. And then you take the derivative of the box. The derivative of the box, which would be the quantity in here, which is 2x plus 5. This has a box within a box, right? Because this has a quantity of x squared plus 5x. That is a box, basically, of this whole thing. And then the whole thing is the box that belongs to ln. So that's why it was the derivative and then another derivative. Okay? Okay, To clean that up, I would say this negative 1/2 power is another root on the bottom. Ooh, 2 roots on the bottom make it a non-root. That's cool. So final answer. I just put this on top, and then I have my 2 still on the bottom, and then 2 roots make this awesome non-root. Okay? All right, last one that we're going to do together, and then you're going to do one on your own and put it on homework helpline for today. Okay? So here is... here is a fun one. So, ln of a quantity, and then that quantity is a fraction. So 2x plus 5 over x squared minus 1. Okay, there are 2 ways that you can do this. I'm going to show you one way, all right? So the one way that we can do this is going to be treating it like it looks like. So just starting right here, what is the derivative of an ln? The derivative of an ln is going to be 1 over. Well, what's 1 over this? It's just the same thing but flipped. So I'm going to start with that. I gotta hide this one. Sorry. A little messy. Okay, I'm going to hide that one. There we go. Something like this. Okay. So here is my 1 over that quantity, right? And then the formula says to take the derivative of this. All right, so 1 over and then take the derivative. So the derivative of this, of a fraction, you guys know what to do, is low d high less high d low, denominator squared b low. So I write that out. So low d high less high d low, denominator squared b low. All right, so I have everything written out, nice and neat. I'm going to start by simplifying this numerator. So everything else stayed the same. See, this one, and then the one on the bottom, right? Numerator, denominator, denominator, they all stayed the same. This numerator, I cleaned up a little bit, okay? Okay, so here is what happens. I'm going to get a pencil so I can show you what happens. So I have an x squared minus 1 here. I have 2 x squared minus 1s here. This one divides away one of those, right? Because I got 1 here and 2 here. And then my final answer, all factored, is going to be a negative out front. I'm going to factor out a 2 because I can. And then the rest of it is just x squared plus 5x plus 1. On the bottom, I have a 2x plus 5, and then another x squared minus 1. So all factored, all done. If you're like, oh, Ms. Tan, you can keep going. You can make this x plus 1, x minus 1. You can, you're right, okay? But this is like a faster version, so I'm just going to write this. Okay, so I want to show you how else you can start that problem, and you'll get the same answer for G. But you don't have to, and it's really up to you. I don't know that either way is easier or harder. But if you have this, you can also rewrite that as, think about those properties at the top for log rules. So when you have ln of a fraction, you can write ln of 2x plus 5 minus ln, oops, can you keep seeing? I'm going to go like this, ln of x squared minus 1. So that is another way to literally start the problem. That's your new y value. And then to get the derivative, you would just do 2 ln derivatives. So the first one would be 1 over 2x plus 5 times the derivative of 2 minus 1 over x squared minus 1 times the derivative of 2x. If I keep going, y prime equals 2 over 2x plus 5 minus 2x over x squared minus 1. Notice how this doesn't look like this. You know why it doesn't look like this? Because you would still actually have to keep going a little bit, and you're going to make this into one fraction. How do you make this into one fraction? Common denominators. So you got to multiply this fraction with that over that. right? So you got to multiply this with this, multiply this with this, and then do some work on the top, and then you will get exactly the same answer. So is it easier or harder? I don't know. It is up to you. But you can use either method for h. So you're going to try h, y equals ln of the quantity 1 plus e to the x over 5 minus e to the x, and then you're going to post how you got to that final answer. Actually, I'll take one of each, okay? I'll take one this way, and I'll take one where you actually do ln and then minus ln, and then you change it back into one fraction. So I'll take two versions. I'm going to show you the final answer for that. Oh, there you go. I'm going to show you the final answer for that. So make sure you get that as the final answer no matter which way you do it. And then I'm going to ask for 2 volunteers for that. Okay? So you can see both ways. Okay. So good luck. I will see you soon.